So hello, welcome to this video of this playing with .NET Core. So in the last few videos I've been explaining that how we can actually call a Visual Basic library within a C# project. Why am I doing all these things about libraries? It's because I want to basically adapt some of the code from DWSim into my own project. Okay, so this is a DWSim GitHub. Okay, I put this inside the description. Okay, and let me go upwards. This is my experimental branch. Okay, this is DWSim. I've just git cloned it for a while. I can just do git pull because they update pretty regularly. And you can see that there are many things they do update. Okay, unfortunately this is all written in .NET Framework. Okay, so this is targeting .NET Framework. Okay, if I just pick a random folder, which is you have the CS project folder. You look in the CS project, it's a lot more complicated than what we have in .NET Core, and then you can see so many includes here. It's very hard to read. Okay, the .NET Core one is way easier, of course. If you take a look at framework, okay, you search framework here, you'll see this target framework version 4.6.1. This is .NET Framework and it's specific only to Windows. And migrating from functions from .NET Framework to .NET Core is huge amount of work to do because not everything is available. For example, when one uses Windows Forms, okay, let me see. Let me look at the ODE library. Now just take a random one. Okay, oh, maybe not XODE base. No. Okay, let's go to math and we'll go to some interpolation. For example, interpolation.vb. Okay, it will, oh, is it IPOP solver? No. Alright. Pardon. Okay, most of the more complicated ones will be in UnitOps over here. If you take a look at the unit operations, if I want to look at a pipe class, for example, you'll see that it will be dependent on many imports. One of the imports for .NET Framework is this thing called System Windows Forms. Okay, Windows Forms is not available on .NET Core. It's only available on .NET Framework. So that's a big problem in this regard. So again, if you take a look at the VB project, okay, we had a CS project just now. Now we have a VB project. You can see the target framework is 4.6.2. Again, not ideal. You cannot use it for .NET Core just off the bat like that. Okay, even if you change the target framework here to .NET Core, a lot of the dependencies, for example, the Windows Forms and everything else, these things do not coincide nicely. They cannot be put over nicely to .NET Framework. Okay, I mean to .NET Core. Okay, so well, last time we were talking about libraries, so let's look at libraries. Okay. .NET Standard 2.0. Okay. Alright, so remember I was talking about this compatibility issue. So the best way where you cannot just take .NET Framework code and then just copy and paste it into .NET Core. Alright, so what is the solution for this thing? Okay, one of the most standard solutions is to make sure that the target framework here, instead of it being .NET Framework or .NET Core, so version 4.6.2 is .NET Framework. Okay, usually version 5 and above will refer to .NET Core. Okay, so nowadays anyway, version 5 and above, version 2 and 3, these are all .NET Core frameworks. So these are, I mean, .NET Core kind of a version, so to speak. So if you want to move from .NET Framework to .NET Core, okay, or you want to switch interchangeably between the two, Okay, the best way to do it is to make sure the library targets a .NET Standard 2.0. Okay, I have sort of introduced it before, but not really much. But what the main benefit of making sure that the library targets .NET Standard 2.0 is that you can use this same library in .NET Framework and also .NET Core. Okay, so this is from the get-go. This will be the goal. Okay, I hope to actually make some kind of unit operation. Okay, I hope to actually take some form of unit operation like a pipe or a pump. I want to take that code out and hopefully reuse it in my project. Okay, of course the code in DWSim has all these Windows Forms dependencies, which makes it very, very difficult to just copy and paste. So there will need to be a lot of changes that actually come in between. Alright, like this plot and plot access. All of these things will need to somehow be done properly, like redone. Okay, so that's the overarching goal, that we extract the code from here. Okay, but just follow me with this and you will see how hard it is already. Okay, look at the first code, Pipe.vb. It's actually 2819 lines long. So normally you should not make a code that's that long. It's very difficult to read. If I were to try and plug out functions to use, it's very, very difficult. Okay, for example, it's like where do I look for the pipe calculation function? Okay, so this is the pipe calculation function. It takes in some arguments and then and you can see it will actually print a lot of paragraphs here. And then not only does it print paragraphs, it actually has a lot of if loops here. And then okay, what's actually going on? It's throwing exceptions. And where are the comments? Where are the comments? I have no idea what this code is doing just by looking at it. And then okay, there's something called flow packages here, which is probably quite important. It talks about thermodynamic package. And then it keeps going on and on and on. There's so many variables here, and this is the only comment I find, line 406. Okay, it's very difficult to see how these variables connect. If I just keep looking at this, I will not be going anywhere. Okay, and then it will keep going on and on, this code, on and on and on. This is just doing so many things that, okay, it's very difficult. Okay, look at this part. This one, if you study engineering, this kind of looks okay to you. Okay, delta P equals to pressure in minus pressure out. Delta T equals to T in minus T out. Delta Q equals to blah blah blah. And the work done, the H in P minus H out, and then you multiply it by some wind variable here. It looks like a mass flow rate, or I don't know what flow rate in. Okay, and me is really like the me keyword in the VB Visual Basic is very much like the this keyword in C# or the self keyword in Python. It is referring to the instance of the object. Now, if you try to keep following the code, you will just get more and more confused. Okay, and not only is this the problem, if you actually look at if you actually try to trace where all these things come from, you'll see that this public class pipe actually inherits from UnitOperations UnitOp base class. So we'll try UnitOp base class. Okay, let's go to UnitOps and UnitOp base class. UnitOperations base classes will be here, and this is the UnitOperations.vb. 271 lines, that's still fine. It's a must inherit class. Okay, it's called UnitOp base class, and where does it inherit from? It inherits from shared classes UnitOperations.base class. Okay, so let's look for shared classes, and you'll see what code is actually behind. Again, another bunch of things, no comments, no nothing. I can't tell what is going on here. And okay, if I make changes within UnitOperations.vb, things within Pipe.vb will definitely change. If I try to port over one of these at a time, there will certainly be a lot of errors. I cannot tell what's going on. Okay, not the best of ways. Okay, so yeah, that is the thing right here. Okay, so let's take a look at the shared classes UnitOps base class. Okay, look at the support classes, shared classes. Okay, base classes. Yeah, where's the shared classes even? Shared classes here. Let's take a look at shared classes if we can find shared classes. Let's look at base class. And this is the simulation object base class. So this is the unit operations class. And how many lines long? 1000 plus. Okay. It's a base class. It's implements this. And it just goes on longer and longer. Okay. So this is the unit op base class. Inherits shared classes unit operations base class. So I would suppose it's over here. Under shared classes base class simulation object base class. Okay. Does it inherit from anything? It's a must inherit class, so it's not a class on its own. Okay, so this is the thing we are dealing with. And clearly lots of things are going on here. I don't even know, okay, how to actually pry apart this code and try to get something useful out of it. Okay, so that is a problem with this code. I mean, it works all right, but when you want to make changes, when you're trying to figure out what's going on, it's very difficult. Okay, now let me well, if we find it difficult to segregate what's important inside if you find it difficult to segregate what's inside a base class, maybe you go one step back and try to look for the thermodynamics and see how their thermodynamics libraries actually work. So if we go to thermodynamics libraries here, look at this thing called property packages, and these are the property packages that are available. They're thermodynamic models for many various compounds and everything. If we just look at steam tables here, it will be under the namespace property package. So this will contain all the data for the steam tables. And where does it inherit from? It inherits from property packages.property package. Okay, so let's look for the property package class. Okay, I don't know why the class and the everything is like the same. The class and namespace are the same name. It makes it just confusing. And if you try to look at the property packages VB class, 12,000 lines long. Okay. And you try to scroll down and figure out what's going on here. It's again very difficult. So yeah, this was way more difficult than I expected, especially the code, because the code was written like so. Okay, there's just so much going on within one page of code. Okay, so that is very difficult to figure out what's going on. Okay, so you can see there are very many imports over here, which is fine. Okay, but no comments again, and this thing is really long. Okay, so these are generally not, I mean, while the code works, I'm very thankful for the writing of this code. It's just very difficult to use. Okay, let's see whether there's any inheritance here. Namespace property packages. Okay, let's see whether it inherit. Yeah, so this property package class is about 12,000 lines long. As you can see, 12,000 lines long. Again, so much is going on here. If I try to pry this apart, it will take very long. So this is not exactly the best of code designs. Okay, so that's something I found out before. So I'm just showing you example of code that's I guess it works, but it's not really up to like best practices. Okay, so there is a proper way to structure your code in such a way that if someone like yourself or me we come in and take a look at what's going on, you don't get lost so easily. Okay, so right, even doing the thermodynamics property package, it is going to be difficult. So yeah, that's a problem. Okay, so what do we do? Maybe we go to the underlying codes. We start from the bare bottom of the DWSim to see how it works, and then maybe we build our way up. Okay, the most basic of all these packages will be DWSim Math, and you can see a lot of mathematical methods here. Some are very easy, such as a quadratic solver. And this is a very simple quadratic solver here, and we can just copy and paste the VB code, Visual Basic Code, over and to .NET Core, and there should not be a problem at all. Okay, so I have done this, and then okay, let's say we import some of these lower level libraries. What then do we do? Okay, how can we write code that, well, it doesn't look like this, 12,000 lines long. Okay, 12,000 lines long, and it's very difficult for someone new who's coming in trying to figure out what you're doing, and you're totally lost. Okay, how do you do it? Okay, so the standard procedure for making for tidying up the code, so to speak, is called refactoring. But even like switching over from .NET Framework to .NET Core is not a strict refactoring anymore, because there's a whole new kind of environment. I'm trying to make it cross-platform, whereas .NET Framework is strictly for Windows. Okay, unless you are using Mono for Linux, which I do not aim to. I want to stick to .NET Core because I don't want to learn extra thing. I don't have the time. Okay, basically. So, and better still, the later versions of .NET Framework, .NET Core are definitely much nicer to use. They have new features, and if you take a look at their CS project files, for example, okay, in .NET Core YouTube, if you take a look at their CS project files, okay, look at the .NET test, look at the CS project file. You look at this is way neater. There's so little items here, whereas for this CS project file, the old CS project file or the VB project file, like here, so many lines of code, just data overload, just too much data. Okay, so that's not ideal. That's definitely not ideal. So yeah, we want to kind of keep up to date as much as we can. Do not write things the legacy way, and of course we want to write it in such a way that we want to write our libraries in such a way that we can actually use it for .NET Core and .NET Framework. Okay, so these are the goals here. So before we start, how should we adopt best practices? So okay, a friend who is working in a technology company, I don't even know which one now, or rather, even if I know, I will not say. Yeah. Okay. He shared with me this solid principles. Okay, how do you make your code readable so that if you are coming from outside like me, you don't mess around with your code reader. Okay, so there are a few principles we can take from here. Okay, the solid is actually an acronym which tells you the best practices, if not the practices we all should abide by when we are writing new code. Okay, of course in the earlier videos I did not use solid principles at all, but well, if you look at other people's code and you find it so painful to even read their code, even one file, you'll understand why solid principle is it's best to abide by these principles so that you tidy up your code. Okay, first thing first, single responsibility principle. Okay, disclaimer first, I'm not a computer science student. I did not take computer science. I'm an amateur like most of you, so I'm just learning this thing along with you. Okay, you can go read this up on your own. I'm just doing a very kind of a dumbed down version. Yeah. and even my explanations may not be 100% correct, so do check me on this. Okay, but I will just read and I'll say, you know, what this means for our code. Okay, first thing first, this is called the single responsibility principle, otherwise known as SRP. So what's a single responsibility principle mean? Okay, if you take a look at this article, you can read it more yourself. But let's look at this class called area calculator, which is supposed to calculate the area of, well, this class is square, this class is circle. Okay, squares will have a side length, circles will have some diameter or radius length. And this area calculator, by its suggested name, should only be there to calculate area and do nothing else. However, it's actually doing something even more than calculating area. There's this function over here, okay, obviously not in C#. This is not a C# code. I believe it's Java or something. Okay, it doesn't look like C# to me because there is a function thing here. Okay, in C# we have to specify the return types, either double, void, integer, etc. So this is not C#, but roughly you can get what's going on here. There's a public function, or which a sum. Okay, functions are methods also. Okay, which calculates the sum of the areas, or at least calculates the area or the sum of areas. Okay, there's a function here that gives an output. It's a print function that actually takes this area data and tries to put it into some form of a format. It is trying to print out. Okay, so this area calculator is trying to do too much. Okay, it's calculating the area, which is what it should do, but it's also printing out this what do you call that? Printing out code. Okay, or printing out results. Okay, printing out results. Okay, this should not be the case. Area calculator should only calculate errors, not print out results. Okay, so this whole point about calculating errors, that is one function of this class. This printing of output is the second function of this class. So actually you should not have a class like this where you have code behind that's actually calculating area and then also trying to sort out how the output should look. Okay, so you can see that the area problem, the output method area calculator handles the logic to output the data. Okay, this is from DigitalOcean. It's not my article, so I'm just saying that this is a good article to read. All right. So how should this class be written? Okay, you should segregate this part from this part. Okay, should segregate both of these. So your area calculator class should only be the part which actually literally calculates area. Okay, right, so where is this? Yeah, single responsibility principle, one class, one function. Okay, so where does this print function go? You should put it in another class. For example, this class is called sum calculator outputter. So okay, this sum calculator outputter will have a dependency injection. Okay, calculator will be put in. As you can see, the calculator we put in, and and then it should be output this HTML and handle output. All right, so it takes in this dependency, it calculates output, and then you're good. Okay, so what's actually going on? How should you write the code? Okay. We should separate this area calculator out into this part and the part that handles the output. So two separate classes are made. One is the sum calculator outputter. Okay, one is the area calculator. Okay, that doesn't do printing or doesn't do outputs. Okay, so this is what a single responsibility principle is about. One class, one function. Don't make it do any more. If you are going to make it do more, do dependency injection. Do not do anything else. Okay. Alright, second thing, I'm going to not be in order, right? For these solid principles. you can see that this area calculator here is actually a class type. It's not an interface. So I want to bring us to the second part. Since we already learned dependency injection, you should not put this area calculator here. You should put interface area calculator. So this is the interface segregation principle, or rather the let's see. Yes, maybe the better one is dependency inversion. Okay, I'm kind of skipping a lot of things to the last part. Entities must depend on abstractions, not concretions. It states that the high-level module mustn't depend on low-level module, but all of them should depend on abstractions, meaning to say interfaces. So we did interfaces before, right, for dependency injection, and this enables what we like to call loose coupling. Okay, so if you can see the single responsibility principle code right here, it doesn't obey that principle because area calculator is a concrete class type, meaning to say you can see all this code at the back over here. Okay, whereas interface only says, okay, I have a public function construct, I have a public function sum, I have a public function output, or okay, we'll not use the output here. Yeah, I will have all these functions. I will not say what goes on under the hood. I will actually make a class that implements an interface. So that is dependency, I guess, dependency inversion. You're supposed to always have interfaces, okay? But of course, it's slightly more than interfaces as well. Yeah, there's more than just interfaces, but the general rule of thumb is that you should always have interfaces when you want to build one dependency on another. So you can see here, the correct way of writing the code is to do dependency injection via in this case there's a SQL server or something. Use the interface. Okay, use interfaces. Okay, interfaces. So that's the second, but actually the last principle also in this solid thing. Single responsibility and dependency inversion. Okay, so one class, one function, and if you need more things to be done, separate them into two classes. And if you want to call one class from another class, use the dependency inversion, meaning to say always use interfaces. Alright, almost always. Okay, otherwise they'll be too tightly coupled, and changing one thing will change too many things as well. Okay, I would say that at least for this code, alright, over here, you will see there are some interfaces here actually. See, it implements a lot of interfaces here, and this is good practice. I must commend that. But again, the comments are little. Yeah, the comments are very little. I can't really tell what's going on, and obviously it doesn't obey the single responsibility principle because it's just doing too much within one line of code. 12,000 lines. Not the right way. Okay? Not the right way if you want to make your code readable. To the computer doesn't really matter, but to humans it matters. Okay? So yeah, so trying to refactor this code will be definitely an issue. Okay, even make it work. Okay, let's take a look at some other principles. Open close principle. I have not really used this myself. Okay, open close principle. Objects or entities should be open for extension but closed for modification. So the example here was the area calculator thing. Okay, example here is the area calculator thing. It will have all these concrete implementations here. All right. Let's say okay. The scenario is this: for let's say a square versus a circle, there are different ways of calculating area. So you kind of need to supply a length scale, maybe a radius or side. But the moment there's a circle, you have to specify that the shape is a circle. Then you'll calculate using pi r square. Otherwise, use r square for a square. Okay. But if you want other shapes as well, like rectangles, triangles, all that, Okay, you're going to have to actually extend your if loop here longer and longer, right? So that's not a good thing, generally not good. So in the sense that this says that a class should be extendable without modifying the class itself. So you don't want to keep adding if loops. If you want to extend the functionality of an area calculator, you do not want to extend if loops indefinitely. So that's not good. Okay, so yeah, you do not really want to get it. So how would you work around this issue if you have so many shapes for this, and then you want to so-called calculate the area of each shape? So the way to do it, one of the ways to do it is to actually put the area calculation thing into maybe the square class. Okay, square class. Squares will have an area function. So you take out all this logic and you sort of put it into the square thing right here. Okay, square itself, I don't know what its function is supposed to be, but yeah, I don't know what its function is supposed to be. But if you say it's an area calculator, make sure that the class just calculates area. But it looks like the square class is just there to hold every single thing here. Yeah, I don't know whether this is the best way. It seems to be okay from this perspective, but yeah, I don't know if it's the best way, but yeah, I think okay, it works. It's I hope it's readable. Yeah, but that is at least my understanding of the open close principle. Why is this good? Because that if you actually put this area function into each of the classes, okay, this area function can be fed into the area calculator right here. Okay, fed into the area calculator right here, and then this area calculator, okay, over here, area calculator, what it will do is that it will call the function. There will be some dependency injection. So let's say you put a circle in as a dependency injection into this sum function. Okay, what you will do then is to activate the area function within this circle, and that will be it. Okay, so what it does is that it will make this area calculator class much if you want to add pentagons, if you want to add cubes, or all of these things, or spheres, you will be able to calculate all these areas as without changing this area calculator class itself. Okay, you have many different scenarios or many different shapes where you can calculate area, but yes, the area calculator class will just call the area function from within each of the shape classes. Okay, so square, circle, and all these are here. Again, I don't really of course I don't really like the way this is done, because for square class it will mean that any and every function that's related to a square can be shoved in here, and then it'll get very messy as well, and it kind of in a sense, at least from my perspective, doesn't really follow that single responsibility principle so well. It says a class should have one and only one reason to change, meaning that a class should only have one job. Clearly speaking, the square class has too many things to do. Okay, so it may not follow that single responsibility principle so closely. Okay, but anyway, this is open close principle. Okay, the main thing is that as the number of shapes increases, you can always just code in the ways of calculating area, not inside the area calculator itself, but rather inside each shape. Okay, each of these shapes. Okay, so yeah, if you have such classes that are big, generic, I do not know if this is a good way of doing it. But yeah, that's that. Okay, that's my understanding. I don't have very good understanding now, but let's move on. Okay, list call substitution and interface segregation. Let's go for. I'm going to go for the easier one. At least this one's easier to understand. It says a client should never be forced to implement an interface it doesn't use. Okay, or clients shouldn't be forced to depend on methods that they do not use. Okay, this one's simple enough. At least the concept is there. So if you have an interface, you have an interface and an implementation. That implementation, I think you should not. Yeah, if that implementation is meant to implement certain interfaces. Okay, forget it. I think I'm not going to do this. Yeah, this one is something maybe I will take a second look or third look. When I'm more clear myself, then I'll talk about it. List call substitution, I kind of get it. Okay. Yeah. This is the gist of it. Means that every subclass or derived class should be substitutable for their parent or base classes. Yeah, so we saw this happen in MariaDB when we are trying to do databases. Yeah, but I think that's it for now. I myself, I'm not clear. I have not actually constructed code using this list call substitution and interface segregation principle. But probably we'll try to at least have this single responsibility principle, open close principle, and dependency inversion principle. At least we implement this sort of things. And then, yeah. Once we master this, then yeah, we'll talk about open list call substitution and interface segregation. But this interface segregation, yeah, maybe I'll talk about this next time. Okay, so this is just a rough discussion. Okay, things are not that clear, but this is the right direction with which to write object-oriented code. Probably not like this, where you have 12,000 lines in one. If you can avoid this at all, avoid this. It makes the code hard to read. Okay, it makes the code very hard to read. Okay, I understand sometimes people like to condense all their code within one file so that you don't have too many files here. But if it becomes a 12,000 line long code, it'll be very hard to read as well. So I'd rather have many files rather than many lines in this regard, and always put comments. Okay. Anyway, that's just my rant. I'm not perfect coder, but now as we read other people's code, we'll understand why it's important to try and adhere to these solid principles as far as possible. Okay, I think that's enough for this video. If I ever get to understand what the other principles are, then I'll then talk about it. As of now, I don't really know it because I have not applied it myself. I have not tried to write large amounts of code that actually use these principles. But of course, you can read this article, try to understand it yourself, and roughly get the concept. But in my opinion, is like, yeah, I don't know it well enough because I have not written code that uses these principles, all 5 principles here. Okay, but that's where I am. Okay. Anyway, see you next time. Enjoy.